Thank you everyone. Please settle down. It's my pleasure to invite Dr. Malay Mirda for the Learning Lab on establishing nutrition surveillance system and analyzing longitudinal data. This Learning Lab is organized by BRAC University, and now I would request the host for this Learning Lab, whoever is it you, Doctor? So I would like to invite Dr. Mirda to kindly come up on the stage and give the introduction remarks for the Learning Lab.
So on behalf of BRAC University, we'd like to welcome you to this learning lab. I really like the idea of learning lab. In this session, I'll take you through some of the aspects of longitudinal data analysis and also how to set up a longitudinal surveillance system. And from a practical example, we did something in Bangladesh, and I will share our experience as well. And that practical experience can also be helpful for us and guide us if we want to establish similar system elsewhere. So let me introduce the facilitators of this learning lab. So can you please stand up? Mohammad Mokbul Hossain, who is a senior analyst, statistics of BRAC University, James Prigand School of Public Health. Fahmid Akhtar is an assistant scientist from the same institute. Ali Hassan is a deputy research coordinator. And Professor Mahbub Latif, who works with BRAC University as a scientist, but he is also affiliated with Dhaka University. And I'll also be with this group. Please sit down. So in this session, like we expected 30 people, so this will be a very, close, and also we want to make it interactive so that so you can stop us anywhere, anytime, and ask your questions. So, we'll take you through just to recapitulate about the importance of longitudinal data. And then we'll also introduce to you the nationwide nutrition surveillance system we have established in Bangladesh. And then with a practical example, we'll give you some insight about the longitudinal data analysis, what to do, what not to do, and how to do it. Accordingly, the learning objectives of this session is to gain skills on how to establish a nutrition surveillance system. And as I mentioned earlier, an orientation on analysis and interpretation of longitudinal nutrition data. Okay, so first of all, just to recapitulate, why do we need to do longitudinal studies in nutrition? There have been so many cross-sectional studies done, but what is the importance of longitudinal study? So can anyone give an example or make a comment about the importance? Why do we need to do any longitudinal studies? Okay. Do you have microphones? Okay.
So what I was saying that we can use for child growth monitoring as the Young Lives India study that is ongoing in Andhra Pradesh and other parts of world. So in that we are monitoring the growth monitoring. So how the nutrition status is changing from 0 to 6 children to 9 to 10 years of children. So with that we can understand how the growth is improving and what are the effects that are playing a role. What are the factors that are playing? Yeah.
Okay, very good. So with longitudinal data collection, which involves like repeated measurement of the same individual. So we can actually follow this within person changes. Like in case he talked about growth or changes in weight or height or both the changes. And also like he mentioned a very important point that like what are the factors influencing the growth? And if we can identify those determinants, we can also design and implement interventions. So yes, so you are very right. So I have listed some of these points, like because from this longitudinal design, the first thing we can distinguish is the between and within person changes that are happening. So we talked about the within person change, but like even if we have a big group of individuals, so the between person changes can also be distinguished. And as he mentioned already that like these within person changes can also be predicted and interventions can be targeted effectively. Then the third point we want to make is that when we talk about intergenerational cycle of malnutrition, so it needs an longitudinal study design to see this effect, like whether there is an intergenerational cycle of malnutrition, even to understand that. So we need a longitudinal study design. Then, like even from the cross-sectional studies, we can track changes in nutrition indicators, but longitudinal studies are better suited to track changes in nutrition indicators and also better suited to examine how multiple factors influence nutrition outcomes. At the same time, so when we are implementing cross-sectional study, we cannot capture very well the fluctuation of nutritional status, time-related fluctuation, maybe seasonality, some cyclical trends. So those can be captured very well through longitudinal study designs. And because the temporality can be established in longitudinal study design, so we can also identify the causal relationship with malnutrition and also how malnutrition influences other health outcomes as well. So some other points. One is it can evaluate the outcomes and impact of nutrition-specific and nutrition-sensitive interventions, which also can be done through cross-sectional study design, but longitudinal study designs are more powerful. And it can improve the understanding on how early life exposures to malnutrition influences long-term health and nutrition outcome. So for example, we all know about fetal programming. We all know about like Barker's hypothesis that like malnutrition in our fetal life can also make us vulnerable to having like non-communicable diseases in later life. So without any longitudinal design, I mean, there are other types of design, but like if we want to really establish the causal relationship, so then longitudinal study designs are more powerful and it can surely establish this. And then identification of risk and protective factors. So then from a longitudinal study, as we can establish the temporality, what comes first? Like we don't have that chicken egg dilemma anymore, because if there is a risk factor and a person is exposed to the risk factor and then an outcome occurs later on, so we can make that association. But from a cross-sectional study design, there can be reverse causality and all those different kinds of problems that we can reduce through longitudinal study design. And of course, like from a statistical perspective, longitudinal study design, it can improve statistical power because repeated measures of the same individuals reduce variability and improve the precision of estimates. And it can also reduce bias, especially recall bias. And when we have a longitudinal study design, it automatically like helps us to identify problems with our data. Say, for example, you measured the height of a child like 6 months back. So that child, and maybe it can be 80 centimeter. Then when a data collector or an anthropologist made the next measurement, and if it is 75 centimeter, it cannot happen because, the child height should not be reduced. So it automatically gives you a signal that there is something wrong with the data collection. So, but like from cross-sectional study design, we cannot, identify those kind of issues with our data. And of course, like with better data, we can have better evidence, and we can, of course, support design of programs and develop new policy. And from, as I mentioned earlier, longitudinal studies are more powerful, and that's why like it can better support the study, design and of the programs and also development of policy. So any question? Yes.
You mentioned life cycle approach. Can we divide life cycle approach into various parts in longitudinal study?
Yeah, of course. Like, there are many stages in life.
Yes.
And so if we start from like even fetal life to life after birth, and during the childhood, then adolescence, then adult life. So through longitudinal study design, we can follow the changes of individuals, like at different stages of life, if we can follow the person.
Okay.
Yeah, it can be done. Thank you.
So I understand that conducting a longitudinal study is a tedious job, and taking into the account the budget and every project aspect we think of it, right from the funding and everything and research design. So what could be the efficient way to manage the dropouts?
Okay, this is a very good practical questions. Dropout is a big problem with longitudinal study, and also like dropout can be differentials. The dropout individuals can be very different from who are included in the study, and you can collect data repeatedly. So from the very beginning, we need to think about this dropout. So studies can be designed in a way that, like, if we think that there will be dropout, say for example in an urban slum, if we want to include that urban slum, so we also need to know like the movement pattern of this slum, the migration pattern, and whether people will be migrated elsewhere. And so in some of the longitudinal studies, which are well renowned studies, so they designed those studies in a way that there is less migration, and then from the very beginning they factored in the probability of migration in their study. So that is one way of doing this, understanding the population movement at first. But then population will move, so if there is no geographical variables that were important for that study design, so maybe like you can also follow that participant elsewhere, collect data from them. If there is a need for like filling in questionnaires, so nowadays like the telephone interviews, other form of interviews can be carried out, and also like if there are, many people move to a certain location, then also you can arrange data collection over there as well. So different studies can be taken, but of course this is a dropout is a big problem with long-term study. Any other question? Okay, so so I'll list some of the renowned longitudinal study with different kinds of sample size. But longitudinal studies are very expensive as well. Like it's not, and as we need like repeated measurements from individuals, so there is a need for huge investment. But that like in these studies, one thing is very visible and evident, which is like the, the sample size variation. So that also like is dependent on like the research questions for this study. So for example, one of the like highly cited longitudinal study is Framingham Heart Study. So that was established, so that started in 1948. And like there are some recent initiatives as well, like the PURE study, which is implemented in 25 countries, and then the Singapore study. This is about mother and children, but they have a sample size of 1,247. But like in the EPIC study, so for example, which is about cancer and diet and nutrition, so it has got like more than 500,000 of subjects already recruited in that study. So the sample size can be variable, mostly dependent on like the research questions. But as I mentioned earlier, this is also very expensive. Okay, so now I would like to take you through like what we did in Bangladesh and Bangladesh food security and nutrition surveillance. So in Bangladesh, when nutrition survey started, like the first survey after independence was done in 1975-76, and that was a cross-sectional study. Then they were like in collaboration with Helen Keller International, Bangladesh Bureau of Statistics, and also BRAC University joined that effort as well. But there were like multiple cross-sectional studies carried out at different point in time, and funding through European Union or the government of Bangladesh, and also like the World Bank also supported in 2023. So there were like variable, funding source. There was discontinuation, but from BRAC University, what we decided in 2018, after we got a government grant, so instead of having a cross-sectional or repeated cross-sectional study design, we wanted to establish like surveillance sites all over the country, and then collect repeated data from these surveillance sites. So why did we do that? One is like we need to have better understanding about the epidemiological and demographic transition that is in place. And also there are certain population groups like men. We didn't have any information about their nutritional status, their determinants of nutritional status. Adolescent boys, that was also a population group that didn't have many data available, and also older adults. So that was one of the reasons like we took different kind of population groups in this study and also designed it in a way that we can have repeated measurements. And then, of course, like for planning and implementation of nutrition programs in Bangladesh, and one of the principles Bangladesh nutrition programs follow is the life cycle approach. But if we think about a life cycle approach, we also need information about all the stages of life cycle. So that is one issue we also considered. And then tracking the progress, and we also designed this study in a way that this is at least representative at a divisional level. Like Bangladesh has got 8 different divisions, and so that it can enable planners for local level planning and implementation of programs. And there were several organizations who joined hand for this effort, and we had, similar objective like the nutritional status, dietary diversity, feeding practices in these population groups. At the same time, in adolescents and adults and geriatric population, we also wanted to understand the interaction with the burden of non-communicable diseases, especially the behavioral risk factors and their burdens. In Bangladesh, like we selected 64 sentinel sites in the rural areas, 16 in the urban areas, and 10 in the slum areas, and it was So this is the study site map, and this is like the way we calculated the sample size. It will also give us like credible estimates for each point in time for each population group, and that was also considered. There are some inclusion criteria. So there were like 7 population groups, like 0 to 5 years old children, 6 to 9 years old children, 10 to 19 years old adolescent boys, and 10 to 19 years old adolescent girls, like representative samples for each of these sexes, and then 20 to 59 years old men, 20 to 59 years old women, and 60 plus men and women together. And one of the conditions that was followed is that not more than 1 in each population group in 1 household. And so this, if we think about like these 7 population groups, 0 to 5 years old children, then adolescent boys, adolescent girls, 6 to 9 years old children. So these population groups were kind of independent from each other. All the sampling was done independently, and this is how rural samples were chosen. And then in the first wave, from the rural areas, we went to 11,790 households, and it recruited 21,000 participants. In urban areas, 16 sentinel sites, 3,368 households with more than 5,026 participants, and in the slums, over 2,000 households and 3,645 enrolled participants. And we used like interview questionnaire to collect information about behaviors, feeding practices, household status, food security, use of like cooking oil, iodized salt, all those kind of data. But then measurements were done, like the weight and height measurements were done for adults. We also measured blood pressure and also percentage of body fat for adults and geriatric population. We used these are the devices we used, but it is important to understand that like the devices you use, like the similar devices should be used if possible when we make the repeated measurements. So when we choose devices for measurements, is there any question? Okay.
I'm Dr. Supriya Lakshmi from India.
Oh.
So when you were talking about the inclusion criteria,
Yes.
so if a girl and a boy in the same age group, you said only one is considered. So was any gender made into account? We know nutrition and gender is known to play. So if there is a girl and a boy in a household in the same age range, so whom would you choose, or what measures were taken to account for?
Okay. Thank you very much for this question. Yes, we included a representative sample of both boys and girls. But your question is about if there was a boy and a girl in the same household. So think about like we needed about 5,000 adolescent girls from Bangladesh, and those girls were randomly selected from the listed households. But if there were like 2 adolescent girls, so then we took only 1, not more than 1 from the same households, because then there can be like household level correlation between their behaviors and also nutritional status, to avoid that. But like from 1 household, 1 boy and 1 girl could have been included. But all those samples were selected independently from the sampling frame generated through household listing exercise. Any other question? Okay, so then you see that like this is the household listing exercise when we did that in 2018-19. So in this entire, I mean, this like the sentinel sites, there are nearly 100,000 households. But when we selected samples from these households, so we actually went to only 17,000 of the households, and 30,000 participants were recruited for this study. And during the second wave, so if we, out of these 30,000, so all of them, we tried to recruit them, but some have moved from their dwelling place to other places. But at the same time, this was kind of an open cohort design. We also included new, like if there was a newborn baby in that particular age group, so that had also been included. So that like we can also generate credible estimates for that point as well, and also analyze data longitudinally. So now I would like to invite Professor Latif to take us through this a practical example of how we analyze longitudinal data. Do you have any questions to me? Okay, over to you, Professor Latif.
Okay, thank you, Professor Mridha. So I'll continue from where he finished. So I'm a statistician by training, so I will explain one of the ways to analyze longitudinal data. So this is my plan. So I will give you a brief introduction of longitudinal data from a statistician's perspective, because to me, like you're a researcher of nutrition, but like everything to me are numbers. So like what is the difference between the data if you get from a longitudinal study and from say cross-sectional study? So in terms of characteristics, like, so I'll explain that. Then I will talk about regression models for longitudinal data. So what models you should use and why you should not use the regular models. Those are available for say cross-sectional data. And then I'll talk about, I'll consider an example from this surveillance, and I'll show you some toy examples from this data and one real example. I also show you how to present descriptive analysis and regression analysis like in tables, and also very few R codes. Like I'll show those. So in longitudinal study, like as it was mentioned that each subject is interviewed several times. So you will get more than one response from each subject. On the other hand, in cross-sectional study, you like interview a subject only once. So whenever we are talking about longitudinal data, here the data is like kind of a response, okay? So you are measuring response many times. So if you measure response from each subject many times, then those responses are assumed to be more associated compared to if you collect data from several subjects, like for example blood pressure. So if you measure blood pressure yourself for 5 times, they are more associated than if I take 5 persons and I measure blood pressure 5, right? So that's the main problem. And what happened, like, if you ignore that association, and then you'll have your effective sample size will be smaller. So you will get the standard error estimate, which will be smaller than it should be, because it considers like bigger sample size than it should be. Okay. So that's the main problem of longitudinal study, longitudinal data. Like, so we need some spatial statistical techniques so that you can adjust that association before getting the effect measure, for example. So in longitudinal study, in longitudinal data, we have 2 types of variations. One is called within person variation, one is called between person variation. So if I continue my last example, say, if I measure blood pressure myself several times, so there will be a variation, right? Not each measure will be the same. This variation is within person variations. And if we take 10 persons and I measure blood pressure from 10 persons, then I will get a variations. And that variation basically between person variation. So if you want to plan and plan a study where you want to measure both within person and between person variations, then what you have to do, you have to take a number of subjects, and each subject need to be measured several times. So then you will get 2 types of variation from a same data sets. And so what do you think, like, which variation is more important? Between person variations or within person variations? I hope you understand what is between person and within person, right? Do you have any feelings, like which is more important and why? Like in cross-sectional, you get like between person, for example. But if I measure only myself, I'm the only person in the sample, I measure myself 1,000 times, I get within person, right? And in longitudinal study, we combine these 2. We take a specific number of subjects, and then each subject measures several times. So we get both 2. So now question is, which is better? Or which variation is important and why? Yes, please.
So in my opinion, both would be appropriate and both will be useful, because if we are doing in the cross-sectional part, so we are getting a variation at the population level. While when we are doing at the individual level, so we will be expecting the variation in the outcome over the time. So it would be a false saying that either one of this important. Both are important, because one is capturing the variation over the time of a specific outcome, while the other is giving the population variation.
Okay, thank you. So let me rephrase the question. So suppose you are doing linear regression, multiple linear regression model, simple model. So we all, most of us know this, and there is a measurement of error variance, and that is very important because that variance influence your inference, because all the standard error depends on that. So which variation should we consider in there? Within variation or between variation? No? So should we take within subject variation in that variance measure or between subject variation in the variance measure? So that's very important, because typically within subject variance is the smaller than between subject, typically. And within subject variance is the variation is the amount of variation you cannot ignore. And that should be your error variance. So only in longitudinal study, you can estimate that variance. And that is like a kind of a pure variance. And based on that, you can make your inference, and that inference will be valid. if you ignore that within person variation, then your variation will be combined of between and within, and based on that, if you have any inference, that may not be valid. Okay? So that's why longitudinal study, to a statistician's, longitudinal study is very important because it can give you like better estimate of variation. All right? So that is very important because we all use, even the software use it, but we all use that for interpreting our results. So, so that's why our point here, like we could have like two types of variations, right? And we want to show at the end how the within individual changes are associated with different selected covariates. Okay, so let me just connect, like even if you did not analyze any longitudinal study, you did in a stat class. So if you studied like t-test, so in t-test, if you have a two independent sample t-test, that is kind of a cross-sectional. But if you have a pair t-test, that is basically longitudinal study. Okay, but we never say that in the basic class. So that's now we will extend how to pair t-test can be extended for general regression sense. All right. Any question? All right. So I assume like you all use regression model for independent data, for example, linear regression model for continuous response, logistic regression model for binary response, and sometimes proportional hazards model for time to event data. All these kind of like data types or models can be extended for longitudinal study. So here we will discuss only two types of models. One we call conditional model and another we call marginal model. Both are useful. Both can give you population average estimate. But conditional model can give you subject-specific prediction. But marginal model can only give you population average estimates. But in our surveillance, our goal is population average estimate. So we are not going that much into conditional model. But I will explain like what is the motivation of using conditional model and marginal models. So typically conditional models are known as like linear or generalized linear mixed effects model or frailty models for time to event data. And marginal models is generalized estimating equations, or G is commonly used. But names are not that important. Okay, so let me first start with linear mixed effects model. So mixed effects models are named, like mixed is like a combination of fixed and random. So that's why we call it mixed. And linear mixed effects model is for quantitative data. There is another class of models, so which we call generalized linear mixed effects model. That is like a kind of a extension of say like logistic regression or Poisson regression. But we'll fix to it. We'll talk about only linear part. So in linear regression model, we assume that the data are correlated because there is a subject-specific effect. That is, we call random effect. And our main assumption is if we know that subject-specific effect, then the data will be independent. That means given that the data comes from one subject, and within that subjects, the information or response will be independent. So I know that this is from this subject, then data are independent. That is called conditional independence. So, and linear mixed effect model assumes that knowing random effects is everything. So, or the data are correlated only because of random effects, but nothing else, all right? So main advantage of linear mixed effect model is that you can get two types of estimates. One is population average, whatever we use is in a linear regression model or cross-sectional study, and another is subject-specific prediction. So for each subject, this model can predict like what would be the future values. And linear mixed typing model is very statistical in the sense you can estimate error or residuals, so you can do a lot of residual analysis and other things so that you can make sure that your assumptions are correct. Okay? So, sorry for this slide. So this is just a notation like how we will write down our model. So in linear mixed type model, we, instead of individual response, we model response from a specific subject or a specific cluster. So in this case, yi is a vector of responses. So if I measure my blood pressure 7 times, that means these 7 measures constitutes a vector which we call yi. And this vector or this collection of response is modeled, depends on different covariate like X or Z. There is a difference between X and Z. X is for population average covariates and Z is for random effect covariates. So, this is like this can be considered as a linear regression, multiple linear regression model if you think betas are 0. So this is just an extension of multiple linear regression model. Okay, but estimation is quite different and very hard, very complicated in that sense. And there are some assumptions because here we have 2 types of random effects. One is B and one is epsilon. B is for between subject variations, or epsilon is for within subject variations. Since in linear mixed type model we have both type of variations, that's why we have B and epsilon. But in cross-sectional study there is no like between subject variations, so that's why B is 0, you can only have epsilon. And I already mentioned you can get population average variation, population average estimate and subject specific estimates. So that's why you can write the expectation in both ways. One is called marginal expectation, that is population average, where expectation of response is just X beta. Another is subject specific prediction. So given your random effect, what would be your predicted value? That is called conditional prediction. So that is the second part. Okay, so we can get both those estimates from this model. So that was my brief review of linear mixed type model. If you have any question or comments, you can make. No? All right. So next, marginal models. So marginal model is quite different. So marginal models basically assumes a model for each response. Suppose I have 5 observations I collected from me, and then I will have 5 models for each observation. So at the first state, they assumes that the data are independent, and they assumes a model like a linear regression model. But this model will give you wrong standard error estimates. So what they do in the second step, they consider a new like model, you can say, for variance of the measurements. So usually if you have a, like in mathematical term, if you have a independent response, then there is a covariance term which could be 0. So that is what we do in linear regression model. But here we'll assume the non-zero covariance, so the correlation will be adjusted. So let me say that if you, this is the right thing to say, so if you ignore the correlation in the data, and if you just use linear regression model, your estimate is correct. So you will get the same estimate as what you should get, but your standard error will be wrong. So your test p-value will be wrong, but estimate is correct. Okay, so we need to correct the p-values So that we need another model which is called variance model. So we define variance model in this way. So in this variance model, there is a subject supplied component which we call working correlation matrix. So what is working correlation matrix? You just assume like how the measurements obtained from one subject are correlated. So there could be different types of correlation. Like you can say each pair are correlated similarly. So if I measure today, and if I measure 10 days after, if I measure 3 months after, all are equally correlated, right? Or we can measure over time, the correlation will be lower. Like today's measure and tomorrow's measure is highly correlated, but tomorrow's measures and 10 days after's measures will be less correlated. So these are the different types of correlation which we can assume in our model. So which we call, they have different names. So which we call like exchangeable, which means none of them are different. All pair of correlations are same. We could have autoregressive. So as time progresses, correlation will be smaller. Or we could have unstructured. That means all correlations are different. So it's like user supplied. So you'll define like how your correlation will be. And good thing about this model, if your assumption regarding your correlation is wrong, still you will get consistent estimate. It's valid. Okay. All right. So that's like a theoretical part of the models, and then I will discuss how to use it in real life data. Any question, comment? Okay. No. You can ask if you have any comment. All right. So I hope you understand. Like my goal was to just let you introduce that the longitudinal data brings just correlated response for a statisticians. Okay. So that you need to change your analysis plan. So that's the only thing I wanted to say. And in regression, there are two types of analysis plan. One is called conditional model, another is marginal model. In conditional model has advantage. You can predict a subject-specific response, and marginal model can only give you population average estimates. So the surveillance Professor Medha described, so we'll use the data from there. And we have data on 3,005 children who are measured twice. And we consider continuous responses, which are height for age, weight for age, and body mass index, all are Z scores, and I will only use height for age Z scores, but this analysis can be extended for other responses too. And there are many predictors we had. For example, parents' education, religion, division, place of residence, children's age at the beginning of the study, sex, wave, access to improved sanitation, food security, consumption of processed food, etc. So this is like a summary measures. Like I have shown you I'm showing you the difference in distribution of different Z scores at 2 time point. So you see that height for age Z scores shows there is an improvement, but weight for age and BMI Z score shows there is no improvement. And you can also see that height for age Z score that in 2023, the variation is smaller than the earlier years. Okay. And these are like unadjusted measurement, right? And we can also like consider, though we will not use in the analysis, we can also analyze analysis correlated binary response, for example, stunting. So you will measure stunting from each children in 2018 once and 2023. So you will have a pair of correlated response. And before Z-score is a pair of correlated response which are continuous, but these are binary. So we can show here the transition. So you can see that only around 4% non-stunted children become stunted in 2023, and whereas about about 55% stunted children becomes non-stunted in 2023. So in this way, you can also see the transitions for underweight and BMI. Okay, sorry, weight for age and BMI. So these models, if you want to consider a regression model for this type of data, you have to use generalized linear mixed stepper model, which is quite different than what I'll show now. So this is the only slide I have for binary response. So these are the descriptive statistics, like for example, the parents' education level. We can see that there are more fathers with education level 0 to 4 years than mothers, and there are more mothers with education level 5 to 9 years than fathers. So this is in Bangladesh, a true picture of Bangladesh. And there are about 52% girls in our sample, and average age is more than 2.5 years. Age at the in 2018. And about 80% samples are from rural area, and 20% urban non-slum, and 20% urban slum area. And most of the observations comes from Rajshahi and Rangpur. So you see, and Dhaka has the highest number of urban and non-slum urban and slum area children, and Rangpur has the smallest proportion of non-slum urban and area. So these green and blue are indicating urban slum and urban non-slum, and red is the rural. And there are some variables which can change over wave. So for example, food security, dietary diversity, and processed food intake. So you can see that we presented this summary in both waves. So there is a little improvement in terms of food security, dietary diversity, processed food intake in our sample. And there are two types of predictors. One is called time fixed, for example, sex of a child, and another is time dependent, which could change over time. Say, for example, access to like improved sanitation or wealth index. So these are the two types of predictor which should be like dealt differently in the analysis. So just to give you an example, here food security is the time-dependent predictor. So you can see our original data. So for the first person, right? For the first person, like the ID is 10101. You have two rows for that subject. And in 2008, he was from secured family, and 2023, that family becomes insecure. So there could be a change in their variable. So this is an example of time-dependent predictors. And in longitudinal study, it is essential to understand the data type, so long and wide, because software, different software use the routine, statistical routine. Sometimes they take wide data as an input. Sometimes they take long data as input. So just to give you an example, which I call wide and long. So this is an example in the left-hand side, WDAT. This is white data, and long data, LDAT. So white data, in white data, each subject or each individual has one row. Right? So for example, you can see here, like the subject with ID 10, 10, and 1, it has two responses in 2018 and 2023, both have two columns, right? But in long data, you see each subject had multiple rows. So the number of measurements will give you a separate row. So here you see that unique ID like 10101, it has two rows in LDAT, and the response becomes here HHZ, you have minus 1.94, which was 2018 measure, and minus 2.04, which was 2023 measure. So these two measures are different, right? And most of the software has the code to convert a white data to long data and long data to white data. In R, this code is called pivot longer for white data to long data, and pivot wider for long data to white data. So most of the software has such routine. But it is, you have to understand beforehand, like what type of data your software required. So you will convert the data accordingly. So any questions so far?
Are there any advantages of long and wide data statistically if you have to choose one? So what would you suggest and why would you suggest that?
Okay, thank you. I hope that at the end of the presentation you will understand by yourself which is better, okay? So otherwise I will explain it again. All right, thank you. All right, so yes, please.
Hello, thank you, Bragg, for this very impactful research presentation. Actually, my query regarding your fixed effect and individual effect or cross-section effect. Here, as your time period is relatively short, only 2 years, so at what extent you able to incorporate this fixed effect or individual effect kind of issues in your estimation model? There may be the problem of degrees of freedom as the observer time period is relatively less. How you can manage it?
All right, so let me first make it clear that though our data has only 2 time points, but the way I am explaining, you can use it for any time point. So I'm explaining like more broader sense. So you can use like this sense for analyzing any longitudinal data. But as an example, because this is, we have only 2 wave data, so as an example, we use this one, like this example where 2 time point data. But there are easier way to analyze 2 time point data, but the way we are analyzing it is better because it has more flexibility, okay? And there should not be any problem of degrees of freedom or anything, like we can talk about that at the end, okay? All right, so let's start. So we'll show you, first we'll show you I have 15 minutes, so should I take 15 minutes or 10 minutes? 10 minutes, okay. So first I'll show you how to analyze longitudinal data by using these 2 approaches, and then I'll show you our result, okay? So first we consider a linear mixed effect model. So you understand that in linear mixed effect model, it's quite different than multiple linear regression model in the sense that you have, each subject could have more than one response. So you have to define that aspect to the routine. So that's the only thing, okay? So in R, we use a package called LME4, and there is a function LMER, but I say this is very simple function. Every software has this function. So what we do, we just explain which part is fixed, which part is random. So here you can see that there is a model where HZ is the dependent variable, all others are independent variable. Sorry, pointer is not working, otherwise I can show you. And in the bracket, 1 bar unique ID, it indicates that there is a like subject specific slope in the model we are considering. So that is our random effect. So each subject has a different slope. So instead of a single slope, each subject has a different slope. Sorry, not slope, intercept. Each subject has different intercept, but all subject has same slope. As we have only 2 time point, so we cannot consider different slope for different subjects, because in that case you will have a problem of degrees of freedom. So here we are just assuming intercepts are different but same slope. Okay, so that's and you can see. Okay, before that one, I can show you first the result, and then we'll come back. So in the left-hand side, these are observed data. So we have here 5 subjects. These are like 2018 and 2023 data. So I just draw a line. And in the second graph, we are showing subject-specific estimate. These dotted values are subject-specific estimates. And the solid line black, this is population average estimates. So this is the main advantage of linear mixed table model, where you can get subject-specific estimate and population average estimate. And you can see that each subject has the estimate, each subject has his own model, right, estimate, and which is linear, and slope is same, because I assume all slopes are same. Only difference in their intercept, you can see that they started from different places. So this is like an output of our linear mixed table model. Any question on this? Any comments on this graph? So this is the like a final part. Okay. And what we can do, so we can get estimates and standard error and p-value as linear regression model, and you can interpret this estimate like a population average estimate. But the prediction is quite different. Prediction should be interpreted condition on the random effect. Otherwise, you cannot interpret the prediction. So here, the way we interpret linear regression model coefficient, you can also interpret here. And like Professor Mida shows in the sample size calculation, there is a ICC, so which is called interclass correlation coefficient. Here you can get ICC. ICC is nothing. It is like variation in random effect over total variation. That is ICC. If it is higher, that means the data are more correlated. It is small, that means data are independent. So you can ignore the things. And there are a lot of model selection criteria like AIC, BIC, whatever you know, you can use here. And you can get 2 types of residual, so that's why you can get 2 types of plots of residuals. One is random effect residuals, another is within subject residuals. You can understand that within subject residuals is very smaller than between subject. That means this model is more appropriate. If you see that within subject and between subject is same, you don't need actually random effect models, so you can use the same fixed effect models enough. So here it shows that random effects residuals are bigger. That means between subjects variation is higher. So we need to consider that like random effect in our model. So that is the first part, and the second part is generalized estimating equation. It will give you only the population average estimator. So the function we use here, it is called GLM. So GLM is a general function of regression models when you have independent response, and GLM is the extension of that. And in that case, this routine feed the regression model after adjusting the correlation within the subject. Okay. So in marginal model, I already mentioned that you don't need to introduce any random effect. You just need to introduce a working correlation structure. So in this case, we have only two time point data, so we don't care about working correlation matrix because all working correlation matrices are same because we have only one correlation, right? So here you see that the formula is the model, fixed effect model, and the correlation structure is important. So I assume here exchangeable, but you could assume unstructured and other things. So introducing this correlation structure will tell the routine that these data are from same subject, so that they will not do the they will consider the data independently, right? And the table you see the estimates and other things, and this table will can be interpreted as you did in linear regression model for this case. There is no difference. Only difference is here the standard errors, those are more accurate. These are accurate in standard error compared to if you use a linear regression model. These are bigger, okay? Because when you have a correlated data, your effective sample size is smaller, so your standard will be bigger. But if you consider this independent, the standard error will be smaller, and you will have a lot of false positive results. So that's the main limitation of using independent data when data is not really independent. And here you will see there is a called alpha. This alpha is what is the correlation between like subjects from each subject, between observation from each subject. And this alpha is not like a linear for like continuous data. This is like correlation coefficient, but for binary data, this is not a correlation coefficient. This is just a measure of correlation. You cannot interpret as a correlation coefficient. And there are a lot of model selection criteria also as before. But you cannot do any residual analysis for this model. So that's our, okay, I should add these things. So I have 8 minutes. So, if we have time-dependent predictors, you cannot use a linear mixed effect model, but you can use marginal models. But in that marginal model, you must assume the correlation structure is independence, but there is a sandwich estimator of standard error which will give you correct standard error. So basic idea is that you will start with independent data, but then you fixed your correlation. So when you have a time-dependent predictors, you cannot use linear mixed effect model, but you can use marginal model. So this is the one advantage of having using marginal model in the analysis. And I'm just ignoring this example. Just I'll show you our final model. So in our final model, we contains these predictors: wave, parents' education level, wealth index, food security, access to improved sanitation, area, division, household size, religion. These child age and sex. These predictors are considered in the model, and we considered a marginal model, and this is our result. So after adjusting all the factors, we see there is a 0.4 unit increase in average height for age Z-score over the years. And you can see there is a significant effect of mother education, father education, and also in division. And there is no effect on, there is no effect of religion and sanitation. So let me summarize the results. So what we have learned that we explained what is longitudinal data, what should be the regression models for the longitudinal data, especially when your data are quantitative, and your estimation of the effect is similar to the linear regression model if your estimates are population average estimates. And for our analysis, what we got that average HZ score increases, and the Z scores increases for the children whose parents has at least 5 years of education, and children from non-slum urban areas has average Z score is higher than rural area, and there is no difference between mean Z-score between rural area and slum area. And average Z-score is higher among children from wealthy family, food insecure family, it should be secure family who eat processed food, right? And sex of the child and household size, religion, dietary diversity, access to improved sanitation are not significantly associated to Z-score. So that's more or less everything what I wanted to say. So if you have any question or suggestion or comments, please let us know. Thank you very much.
Thank you, sir, for your nice presentation. Actually, we have done very good job regarding the application of the longitudinal data, though the number of time components is relatively less. But here you have directly used the mixed effect model. Actually, in the literature of the panel data analysis, there is the option for the selection of the appropriate panel data regression model by using different test criteria, whether it may be fixed effect model or it may be a random effect model or other types of model also. But why you are directly used or preferred the mixed effect model, that is my one question. Another question is, in your marginal effect model or in your marginal model, the marginal model can able to address the fixed effect kind of impact on the dependent variable. That is the two specific questions.
Okay, so first question, like why I use mixed effect model, but I did not show you. I compared fixed effect and mixed effect, and I found mixed effect is better, like by using linear or like likelihood ratio test. So that's why that part I did not show. So mixed effect you must use here because the correlation is higher than, you cannot ignore the correlation. And the second point, like, can you say again? I forget the second part.
In your marginal model, can it able to analyze the fixed effect kind of impact on the dependent variable?
Yeah, yes. Marginal model is a fixed effect model, but the standard errors are correctly estimated. But if you directly use fixed effect, standard error will not be correct. So that's the only difference. Thank you very much. Oh, sorry, long and wide format. You understand which is better? Long or wide? Yeah, so if you use wide, then you can have time-dependent predictor in the model, in the data. And if you have only long, so if you have long format data, you can include time-dependent predictor. But if you have only wide format data, you cannot include time-dependent predictors. So you must have long format data for longitudinal studies. All right, thank you very much.
Thank you so much. We will just wait for our other two Learning Lab folks to come in to start the final session for the day. And in the meanwhile, can I have somebody from Shangri-La to arrange the setup on the dais? IFPRI folks, can you help usher people inside who are coming out of the Learning Lab 1B and 1C? The online participants can stay because we will be using the same link for the plenary session. Requesting everybody outside the Lotus Ballroom to please come inside. We are about to begin the final session for the day. Can everybody please come inside the Lotus Ballroom?